Welcome to the g.c.2.6 and 2.7 notes. The goal today is to apply the properties of an inscribed angle. An inscribed angle is an angle that has its vertex on the circle. That's depicted for you in this first diagram here. Angle B is inscribed to arc AC since that's what it intersects. And if you look at the theorem that goes with this angle and arc relationship, then you have that if an angle is inscribed in a circle, then its measure is half of the arc it intercepts, which is shown in the diagram below here. If you have that the arc is x degrees, well, the central angle is x degrees, but the inscribed angle that intersects that arc is x. You could also assign x to the inscribed angle, which means that the arc it intersects is going to be 2x. And so there are two theorems that are outlined from here. There's a proof very reasonable that you could look at on your own time. The theorems, though, are common sense given the properties of an inscribed angle. So if two angles are inscribed and intercept the same arc, then they're going to be congruent, naturally. And then if one side of an inscribed triangle is a diameter, then the angle that's opposite that diameter is going to be a right angle because it opens up to half of the circle, which I've just outlined in the diagram to the right of that theorem. So looking at a few examples and trying to apply this concept, we have that the central angle here is 38, and we want to get the measures of angles 1 and arc 2. And so the central angle opposite this arc is going to apply its measure and make measure angle or arc 2 be 38. And then since 1 is inscribed to that arc, it's going to be half of 38 since it's inscribed, and that is going to be 19 degrees. If you look at the second figure, we have a similar situation. Angle 2 is a central angle to the arc it intercepts, which is going to be 114. But 1, since the sides of the angle intercept 114, 1 is inscribed, so it's going to be half of 114, which is going to be 57 degrees. And if you look at the last example here, a little bit of a different diagram. We have that 18 has a vertex on the circle, so that's inscribed to arc 1. So 1 is going to be 2 times 18, which is going to be 36 degrees. And then from here, we have all of the arcs except for this part that I'm squiggling. And so we could take 134, 100, and 36 away from 360. So that's minus 100, minus 134, and minus 36. All right, we get that the squiggly arc is 90, which means that the angle across from it, since it has its vertex on the circle and the arms of the angle, the rays of the angle intersect the circle, it means that angle 2 is going to be half of the 90, which is going to be 45 degrees. The last theorem addresses a quadrilateral that is inscribed in a circle, so that means all of the quadrilateral's vertices lie on the circle. And it says if a quadrilateral is inscribed, then the opposite angles are supplementary. So I've assigned W, Z, X, Y to the opposite angles, and just W plus Z is equal to 180, and X plus Y equals 180. I probably could have also just said A plus C equals 180, D plus B. There is a proof that follows, but I'm going to go ahead and jump straight into the application. So previously we could have done some really weird math with inscribed angles. Not weird, but just complicated math. Whereas here, I see that all of my vertices lie on the circle, and so I know opposite angles are going to be supplementary. So 64 and 1 are supplementary, which means 180 minus 64 is 116 for angle 1. And 58 and 2 are across from each other, so 180 minus 58 is going to get me 122 degrees, and that's the measure of angle 2. We have a similar situation, so straight away I see that all the vertices of the quadrilateral lie on the circle. Here, we have a unique situation in this corner because we have an angle that opens up to half the circle. So that inscribed angle is 90 degrees since it's half of 180, which is half a circle. And so similar to the first example, we have that opposite angles are supplementary, so 1 is also going to be 90 degrees. And then we have opposite angles here, 118 and 2 are going to be supplementary. So 180 minus 118 is going to be 62 degrees for angle 2. And looking at this last example, a lot of different angle relationships that you could work with. Again, we could get super complicated, or we can try to make it as easy as possible. So one of the first things that jumps out at me is the 102 is a central angle, which means that this arc I just squiggled is going to be 102 as well. And I see that angle 1 is half of that intersected arc. So that's going to be 51 degrees for angle 1. I cannot use what I'm going to outline in turquoise here. I cannot use the angles are supplementary in this opposite angles are supplementary in that turquoise quadrilateral, since the center is not inscribed. It's not on the circle. But I can, in what I'm outlining as pink, say that this quadrilateral is going to have opposite angle supplementary since all of its vertices lie on the circle, which means angles 1 and 2 are supplementary. I just found that angle 1 is 51 degrees, which means that 180 minus 51 degrees will get me 129 for angle 2.